Hello guys, electrostatics of conductors. Question is, if we have a conductor with a cavity as shown here, this is a conductor, metal conductor, and if it is given a charge Q, will the charge be present on both inner and outer surfaces as shown here or not? Let's see. So in the first figure we have an uncharged conductor with a cavity inside it. Hollow portion. Cavity means this is a hollow. Here we can say vacuum or it could be air, but there is no metallic material present here. Now suppose from outside a charge Q is given. Initially the metal is uncharged. Now we give a charge Q to the conductor. After this charge Q is given, now this charge has two surfaces. One surface is S1, outer surface, and another surface is S2, the inner surface. It is well known that the charges stay on the surface of the conductor only, but what is more appropriate answer? Will the charge stay only on the outer surface, or can it stay on the inner surface also? Let us try to answer this question with a reason. Let us start. Say if by any means or by any cause charges are present on the inner surface of the conductor, then mutual repulsion will happen between them. Due to this mutual repulsion, they want to move far away from each other. So can they move away from each other? Of course, they can travel through this metal conductor. Metals allow the flow of charges because metals are good conductors of electricity. So these charges will travel through the conducting metal, and after traveling, see, they are going far away from each other. They are going towards the outer surface. And so finally, they will reach the outer surface. Hence, it is proved that the charges cannot stay on the inner surface, because by any means you give charge on the inner surface, then due to mutual repulsion from each other, these charges will travel in through this metal part and they will reach the outer surface. Therefore, charge will be present only on the outer surface S1, and the inner charge S2 will be charge free. But there is another special case. What if a point charge is placed inside the cavity? Then definitely we have some different answer that I will give in the next video. Thank you for watching this video. Kindly press the like button and subscribe my channel. Thank you.